At the moment, I am working on the star data on two things. One is the beam energy scan data. We've just finished looking into the energy loss to see if there is signals of that, and we hope to have that published soon. And then I'm also looking at the P-gold data to see if we can see any evidence of jet quenching in the small systems, because we seem to see evidence that there's a flow or a quark-gluon plasma created in the small systems. So we're trying to make the measurement to see, can we see any signs of the jet quenching, which is another signature of the quark-gluon plasma. So STAR has a number of new results. We're very excited to have 18 talks and 33 posters where we're presenting data from the top energy, our gold data, all the way through our energy scan down to the fixed target data, which is at very low square root S, trying to see evidence of the critical point, and including the small systems. Key amongst these data that we're showing are the new heavy flavor results. So we had a heavy flavor tracker in that allowed for very precise vertexing, and at this conference we're releasing a lot of data from that one, including the particle, the D0 particle, and the evidence that it's highly suppressed over all PT, and that the lambda C, which is a baryon containing the charm quark, is highly enhanced in these systems. And so what we see is that while charm as a whole binary scales in our most central gold-gold collisions, we see that the hadronic mix-up between the different charm mesons and baryons is very different to the baseline proton-proton collisions. And so we have high statistics data over a number of energies and over the number of centralities to see how this develops as a function of the centrality of the collision. And we're also looking into decorrelation measurements to have a look and see how the longitudinal expansion of the quark-gluon plasma is. So one might expect that it's very uniform across the expansion in the Z or in the rapidity direction, but what we're seeing is evidence of a large decorrelation if you look at negative pseudo-rapidities compared to positive pseudo-rapidities. So you see sort of a twist of the system as it expands and as the two beams go away. And so that's much larger. It was already seen at the LHC, but what we see at RIC energies is a much larger decorrelation, and we're probing more deeper into what this scale is. So what I'm expecting to see is it's very interesting to see the comparison of the theory to the data that we've released. Some of it they've been expecting, so to see are the predictions that are coming from the theory in agreement with what we're seeing with the data. So that's the sort of the first thing that I'm very interested in seeing. There's always a wealth of new theory data that comes out. And the other thing that I found very interesting that I wasn't aware of because I haven't been working on it is looking at the wealth of the new xenon-xenon data that's coming out and how that fits in to the whole picture of the square root S dependence and the light systems versus heavy systems to see, can we predict from what we've measured in gold and lead what was happening in the xenon-xenon. So that's been nice to see.